Today I'm going to show you how to clean data in R. Welcome to the channel. My name is Ilko and I'm the data rockstar. Today I'm going to show you how to clean the data in R programming to speed up your process to clean the data before you start with your analytics. It is very important to clean your data before you start with any other work on your data. And that's because of the garbage in, garbage out approach. If your data is not sanitized and there's information in your data that is incorrect, you will get wrong insights that leads to wrong decision making, that leads to big problems in the end. So if you're struggling with data sanitation and you're thinking the manual approach is way too long, I have to import everything into Excel and it takes ages before I'm finished with that, this is the video for you. So I'm going to show you a great approach, what I found in R programming. So R program is a free tool, a free programming language that you can download from the internet. I'm not going to show you how to do that. I'm expecting from you that you already know a little bit about programming, a little bit about data analytics and the R language. So I'm not going to show you step by step how to do things. I want to show you how to clean your data. So let's focus on that. If you want to learn more from me about R, leave a comment and like behind so that I can always come back to that if there's enough audience for that. But at this moment, I just want to show you how to clean your data. So let's go into R. Here in R, I have prepared for you a nice script. And I'm not going to share this script with you. I want you to learn how to do this yourself. So you have to write it yourself from scratch with your own data so that you can learn from the mistakes that you have in your data. So let's go ahead with this one. So the first one I have here is the first line. Let's install the package tidyverse. Tidyverse is a package that is combining several different packages like the dplaner, ggplot, so that you can use that into your data analytics. It's a really great library to use. I have it already installed, so I can skip to the third row, and that's the library tidyverse. Library says let's incorporate that or import the tidyverse, and let's tell R that I want to use it. So I press Alt Enter, and you see in the console below that the library tidyverse is loaded now. Next, of course, we need the data. I have a large data set, about 10,000 rows of sample data. I created that in R as well to create the data. I forced to have errors in it. I forced my script to say there's some NAs, there's some missing volumes, there's some duplicates. So this is a great example data set to use in this tutorial. So first of all, I want to read the data. So I have the data on the left-hand side. That is how I'm going to call this data set. I'm going to read.csv. That's the function to read the data into a data set. You see what it means, the file, the header, separated by commas, etc. We can give all the variables, but by default, it's already set up for a standard CSV file. So if I press Alt-Enter after this line, you see on the right-hand side that I have a data set with 10,500 observations. An observation is a row. So 10,500 observations. I can open the data to show you what we have in there. So the customer ID, a customer name, the region, a purchase date, a sales amount, and a product ID. And these are standard data analytics that we can use, standard data columns for the analytics that we can use. So the customer name, we can see how many times the customer has purchased something, which product he's purchased, etc., etc. So this is all made up data. So we have a lot of duplicated customer names. So the customer names are nothing special. We have the customer IDs, the region, purchase date is a character string, the sales amount, that's a numerical data, and the product ID is numerical. So with this data, we can already see that there are complications. If you want to do this manually, you want to see if there is empty strings or if there is any NAs, etc. But it's difficult in R in Excel, you need to know what kind of data is present there, etc., etc. It takes a long time. So there's an R. You have a very simple tool that calls the summary. Summary is it's from the base R package, and if we call that on the data set that we have just created out of the CSV file, we get in the bottom, we get some information. So with all columns in the data set, we get a list of information. So the customer ID, for example, the minimum customer ID is 1. The maximum is 100, so we have 100 different customer IDs. But you see the first quartile, you see the third quartile, you see the median and the mean. Now on customer ID, it doesn't mean that much. But if you look at the sales amount, that's where the interesting data comes from. So we have the minimum amount is 100, the maximum amount 500. Then we have a median and mean. So the median is the exact middle of that data set, and the mean is the average of the whole data set. So they are very close to each other. So we can pretty say that this is a bell curve data set. So it's not skewed to the left or to the right. But we can also see there are 632 not applicables in the sales amount. Not applicables in essence means that's not a number. So we want to look into that a little bit further. We can also see the purchase date. Those are all characters with 10,500. So 10,500 is the length of the whole data set. We can see that this is a character, this is a character, this is a character. The product ID, there's only 5 product IDs, so max is 5. And like I said earlier, customer ID is 100. So we can't do much about these. These are just statistical data that we get automatically. But we can use this information further down to understand more. So this is the first step what you want to do in general with data that you get fresh. You want to understand what the median is, what the mean is, to see if it's skewed or not skewed, but also the NAs. How many not applicables do I get? Now then there's another thing that can happen with your data, duplicates. You can get duplicated data that you don't really want in your data, right? Because you are counting the mean or the median twice or 3 times or even 25 times, depending on how many duplicates you have in the data. But you don't want to just willy-nilly remove that data. You want to be mindful about it. So you create a different table out of that duplicate data so that you can always refer back with, okay, I removed this, maybe I shouldn't. What was the data? What was the information that I had in there? So you want to create a new data table. So that's the duplicated rows. So duplicated rows is based on data. And based on data, we only get the duplicated data. So the duplicated data, we're saying that's full. Everything that is duplicated and only get this duplicated row. So that's existing twice in the data set or multiple times. So once we recreate that, we get 500 observations. And we can see which row ID it had. So you can see it's all at the end of the data set in my scenario. That shouldn't be so nice organized in the real life scenario. But we can see the customer ID, the customer name, the region, the purchase date, sales amount, and product ID that already existed once in the data. So it removed this one. It didn't remove it yet. It only separated that into a different data set called duplicated rows. We can use that duplicated rows. We can see it here, that's 500 observations. But if you want it nicely in the console, for example, you can print out the n row and duplicated rows to see how many rows there are left. So there are 500 duplicated rows that this system has created. So now we have that in our memory. We can always write it out to a CSV to store them in a separate file before we are removing them completely from the data set. But in this scenario, I'm going to just remove them. So I have removed them with the data and then the distinct data. So distinct means I only want one unique value one unique row. And if there's double, it removes it. So now we can do another one with the summary data. We did it before, the summary data, and we got 632 not applicables. We had a minimum of 100, we had a maximum of 500, and a mean 301.1 and a median 301.2. Very close to each other, not skewed at all. So now we have nearly the similar information, but we see that the not applicables are a little bit less. So we had 632 not applicables in our dataset. That is now 599. That also meant that the median and the mean has changed slightly. That also means that the first quartile and the third quartile is also changing slightly. So we have reduced the amount of data we have. So reduce the amount of numbers, of rows, observations, and with that we can narrow it down to what the actual median is, to actual mean, and the first and third quartiles. So we can create an inner quartile range, etc., to use that in our data analytics later on. So we see that already. We have 599 less data. But there's another issue that we can have in data like this, because we have 3 columns, the customer name, the region, and the purchase date as character columns. Character columns is just text columns, right? And that could mean that there's any kind of data in there. So what we want to do is sanitize it as well. So we don't want any empty data because we want to classify it into a certain area. So we first want to highlight it, that it's missing information. Missing information, it's not always a bad thing that there's missing information, but I want to classify it as missing data. So what I do, I'm porting this everything into my original data set again. And I'm saying the data, what I have so far, I want to mutate all columns if. So there's a condition involved. So if I mutate it, but there's only a mutation if there is a column of character. And you see here, that will be the customer name, the region, and the purchase date. What happens if there's something like that? Then it's looking into a new if statement. So then there's an if-else formula that looks at, is that value, what I'm looking at, in that column that I'm looking for the character, is it empty? Is there nothing included in that data? Or you can, if you know there's a certain amount of data that has the wrong classification, you can use this approach as well to reclassify it. So we can change, instead of region west, we can say region east because we don't have region west, for example. So those are extra things that you can do with this approach. But in this scenario, we are using the empty value and then missing. So if I'm starting with my data analytics on this data set, I want to be very clear and very concise that the data that I have was missing. So there was missing information there. So I can filter that completely out of the data if I really want to say, listen, this is not part of the mean or the median because I don't know where it belongs to. But for the full data set, you can include it. So if you're looking for only the regions, so the region west, north, east, and south, you can say omit all the missing data because you are not entirely sure if it was for west, north, east, or south. So you can remove that completely. So that's what we're going to do. We're going to look at the whole data table and look at each column that is a character. And every time there's a variable that is, or a value that is empty, we make it missing. And that's what we did now. So it's a very quick, very fast approach to say it's missing. So now the data in here, if we type in missing, we see that the customer names are missing, for example. So we have a few customer names that does not have any value. So we don't know which customer it was for. We know the customer ID, so we can always trace it back. But in my data set, I do not have a customer name. So if I do an analysis on the customer name, how many products they have sold, I can omit that from the total values because I don't know which customer name it was. So let's go into the NAs. We still have the NAs, right? So if we make a quick summary of the data, let's copy paste this one and put it up here. We still have the NAs. We have the same amount of rows because we didn't remove anything yet. After the duplicates, we only changed the naming or changed the values. So now we're looking at this part. We have 599 not applicables. And the 599 not applicables is a small portion of the 10,000 rows, but there are different strategies to deal with not applicables. So the one way is to make it a character value, saying it's unknown. Making it an unknown value, it's a safe way of putting it into a different table first. So that's what I'm doing here. I'm putting it in an unknown values table. I'm looking at the whole data, and I mutate the whole data across everything. But I'm looking at if there's a condition is not applicable, anything at all is not applicable. If yes, then I type in, or then I rewrite the variable to as unknown. You don't want this into your main data set because there's one caveat about this. I'm going to show you. I'm creating the unknown data table. We have 10,000 observations, but what happens if I'm doing a summary of those unknown values? I got the sales amount, which was before a numerical data, is now a character data. Because the unknown value is a character, so I can't do any calculations anymore out of it. That's why you want this to be in a different data set, so that you can write it out to a different table, different file, so that you can always refer back to what you have changed in the past. From here, we can actually say, okay, we have safeguarded the data. We know it's now a character, but we have unknown data. We can now safely remove the unknowns to start building the statistical data set that we want to use. So we create a new data set in R to stay safe on the safe side. We don't alter the data anymore. So the main data, this is the main data set that we imported from the CSV file. We changed a few values, but we don't want to remove anything at this moment in time, just to be on the safer side, right? So what we use in this situation is the drop NA. So drop NA is part of the tidyverse, and with drop NA, we can select the data that we want to drop. So what this does, it looks through the whole data table, every column, every value what there is. If it's NA, it removes that row completely. So then we don't have the rows anymore in the dataset that has an NA. So we did that. So we have now 9,401 observations, and that's exactly the amount of observations that we left behind with after the 599 observations that were not applicable. So if we do a summary now, we have the sales amounts returned to us. And it's fairly enough almost the same as what we had earlier. It's still not skewed data set. It's not skewed to the left, not skewed to the right. It's a nice bell curve. It's a normalized data. We have the median of 301.9, the mean 301.3, etc. So, but we can see at the bottom, there's no NAs anymore. So all the NAs are removed now. There's also another approach, and that is to change the data with an NA to the mean or the median. Depends what you prefer, or depends what you decide as a company. So the mean is 301.3. So what we can do, we have a similar approach as before. When we remove them with NA is unknown, etc. But now what we do if we are mutating the column sales amount, we only mutate it at the moment it is NA under that column. So no other columns are involved. We only look at the sales amount. If that's NA, we are saying the mean of the sales amount, and we remove the NAs. So if it's not applicable, the mean, we remove that. But at the end, we have the, if it's not applicable, so if it's applicable, it is a number, we just populate it with the normal sales amount. So we rewrite the column, so to say, with the sales amount. If we Alt-Enter this one, we have now the cleaned data. So we have 100,000 observations, as we had before, 100,000 observation, 100,000 observation. But here, the removed observation was less than what we originally had. So the cleaned data is now every value that had an NA in the sales amount. So we have to do this for every column that we want to do. So in the sales amount, every value that was NA is now the mean of the sales amount before the application of this application. So if we summarize it, now the median is exactly the same as the mean. The first quartile is slightly changed, but we don't have NAs anymore, as you can see at the bottom of this sales amount. But we still have the same amount of data as before, and that's because we have created a mean. And that's another approach how people use that in situations with cleaning data. So now we can say this cleaned data is actually clean, 100% clean. We have no empty columns. If it was empty, it's now saying missing. We have no duplicate data. And the sales amount, if that was NA, it's now the mean of the data set. So we can start with our analytics of the data. So that's pretty much it. Now we have a clean data set. We can write it out to C3 and start populating it into Tableau, in Excel, whatever you want to use to start creating your analytics and the insights out. It's a great way. It's a fast way. If you run this script, it takes you 5-6 seconds before you have a clean data which you can use straight away. So that's it. Thank you so much for watching. If you have any questions or you like this video or anything that you want to share with me, leave a comment, like this video, subscribe to me, and maybe we will see each other in the future again. Thank you so much.